Okay, so now I would introduce the jury members to the present year. So Lakshmi ma'am, she is currently heading the Department of Electronics and Telecommunication Engineering at RV College of Engineering, Bangalore. She is a senior member of IEEE, fellow of IETE and member of ISTE. She has over 28 years of experience in teaching, administration and research. Her research interests are in emerging communication technologies, and she has guided one PhD scholar and a number of UG and PG students. She has published many international journals and conferences, judged many project contests, currently executing project sanctioned for 15 lakhs. She is a mentor for research projects for Samsung R&D. She's been the session chair and technical committee member reviewer for many IEEE international conferences. It's our honor to have you here, ma'am. Thank you for joining us today.
Thank you.
Yeah, now I would like to introduce our Dr. Setu Selvi. She's a professor at Department of ECE, Ramaya Institute of Technology. She's obtained her PhD from Indian Institute of Science in 2001 under Professor of Image Compression. She completed her BE from Tyagarajar College of Engineering, Madurai in 1992 and MB from Anna University in 94. She's joined the faculty of Department of Electronics and Communication at MS Ramaya Institute of Technology in 2002 as assistant professor. She has numerous publications to her name in the field of machine learning, pattern recognition, and signal and image processing. She has 4 PhD theses to her credit, and at present she is guiding 2 PhD students in the field of signal and video processing. She has many funded projects to her credit and has a very healthy interaction with industries and research organizations through MOUs and interaction with industries and research organizations through various MOUs. Her fields of interest are digital image processing, machine learning, deep learning, video processing, character recognition, and biometrics. She's authored a paper titled Image Algebra and Image Fusion in the book Data Fusion Mathematics, and has been listed as a noteworthy technical contributor by Marquis, Who's Who, 2009. She's an IEEE senior member and is responsible for starting the IEEE Signal Processing Society in Ramaya Institute of Technology. She's the IEEE SPS chapter and regularly volunteers for various executive committee positions in IEEE Bangalore section and also Signal Processing Society chapter. Thank you for being here, ma'am. Thank you so much. Okay, so let us start with the project presentations now. Firstly, I will call upon the third eye for the blind project title from JSS Academy of Technical Education. Are you guys here? From JSS?
Yes.
Nishchit. Okay.
Yeah,
So you will be given 15 minutes, 10 minutes for presentation and 5 minutes for question answers. So
okay.
is your presentation ready?
Yes, ma'am. 1 second, we'll
Yeah.
share the slides.
Yeah, you can start.
Good morning, everyone. We thank the organizers for giving us the opportunity to present our idea. So we are from JSS College. Our topic is Third Eye for Blind. First, starting with the abstract. Uh, the millions of people in the world whose vision is not perfect wear glasses, but according to WHO, 39 million people are estimated as blind worldwide.
Nishchit, sorry to disturb.
Yes,
Please put it in the presentation mode.
Okay. Yeah. According to WHO, around 39 million people are estimated as blind worldwide. For those who are blind, existing methods that merely assist them are not just enough. What they need are alternative methods by which they can navigate with greater comfort, speed, and confidence. By taking these into consideration, a wearable prototype is designed which can resolve the problem of existing methods. So our topic name is Third Eye for Blind. Going into our introduction, visual impairment is known as partial or complete loss of sight. Blindness may be caused by injury, by lesions of brain or optic nerve, by disease of cornea, etc. So we have taken this topic With the improvement of living standards of people, we have become so materialistic that we have forgotten the physically disabled people to live a tough life. Eye are prime sense of organ in perceiving the outside environment. So the domain which we have chosen is IoT, Internet of Things, which describes the network of physical objects, things that are embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data with other devices, systems over the Internet. So this is the domain which we have chosen. Now going into objective of our presentation, the objective of this project, the third eye for blind, is to design a product which is very much useful to those who are visually impaired and those who often have to rely on others. It allows the user, those who are visually impaired, to walk freely by detecting obstacles. This is wearable technology for blinds, which helps resolve all problems of existing technologies, cost and time efficient compared to existing technologies. The objective is that one of the main peculiarity of this innovation, it is affordable for everyone. The total cost being less than 2K probably. Using these ultrasonic waves to detect the obstacles, notifying the user through vibrations or buzzer sound, it can function very accurately and they only need a very little training to use it to avoid holding a stick which is a bit annoying for them. Going into methodology, this special wearable device will be designed based on Arduino board, which can be worn like a cloth for blinds. This device is equipped with 5 ultrasonic sensors consisting of 5 modules, which are connected to different parts of the body, as shown in the figure, which helps them to detect the obstacles and which makes their life easy. Among them, 2 of both shoulders, another 2 for both knees, and 1 for hand. Using the 5 ultrasonic sensors, blind people can detect the objects in a 5-dimensional view around them, and they can easily travel anywhere. When the ultrasonic sensor detects obstacles, the device will notify the user through vibrations and sound beeps. The intensity of vibration and rate of beeping increases with decrease in distance, and this is fully automated device. Now, these are the components which we are going to use. The steps as shown in the figure. So the final prototype which we'll be developing will be like this. The components required are vibrating motor, head-up pins, and perf board, toggle switches, LEDs, buzzers, and mainly the ultrasonic sensors and Arduino Pro Mini. So going into methodology, the connections of these gadgets are developed as follows. As shown in the figure, we'll fix the objects and develop the figure as shown in the figure. So benefits, we navigate with greater comfort, speed and confidence while making use of ultrasonic waves to detect nearby obstacles and to notify the user through vibration. The first wearable technology for blinds. One of the main peculiarity of this innovation is it is affordable for everyone. So benefits is that benefits they can navigate with greater comfort, speed and comfort while making use of ultrasonic waves, and the expected result is that the system is created and designed for visually impaired people. This device helps the visually impaired people to handle several states and respond to user in every environment. All conditions can be easily met by blind individual using ultrasonic sensor and Arduino board. This device will help the visually impaired people to know about the obstacles in every direction. Case 1. If obstacle lies on the west or left of the person, the device will let the person know that there is an obstacle on the west or left side. Case 2. If the obstacle lies on right, the device will let the person know the obstacle lies on the right. Case 3. If the obstacle lies in front, it will tell the user that there is an obstacle in front. And similarly, the person will know about the obstacle in all directions like black, back, left, right, etc. Going into conclusion, a new concept of Arduino-based visually virtual eye for blind people. The system will be efficient and unique in its capability in specifying the source and distance of object that may encounter the blind. With the proposed architecture, if the constructed with utmost accuracy, the blind will be able to move from one place to another without others' help. So these are the references which I have taken. Thank you.
Thank you, Nishchit. You have any demonstration or anything to show?
Actually, we are developing the project now. We are not yet fully developed it.
Okay. You did not introduce you and your team members, which college, semester, department.
We are, oh, sorry. We are from JSS Institute of Technology, Bangalore. I am Nishchit, and my teammates are Nikhil, Pranav, and Pavan Kumar NS. We are studying in Electronics and Communication 6th sem now.
Sixth sem. Okay. Okay. So now I leave it to the
Yeah,
jury members to ask if they have any questions.
yeah.
Good morning, team. I am Sri Lakshmi.
Good morning.
Nice
Good
idea
morning.
for the, is it a minor project what you are carrying out?
Thank you.
Hello? Is it a minor project what you have
Yeah, we are
carried out?
carrying out the minor project. Yeah,
Okay.
yes, ma'am, yes.
Yes. So first question is, have you made a costing for your project? You have just said less than $25.
Costing? Yeah,
Have you
yeah.
estimated the cost? See, you are making a product, no?
Uh,
You have to sell it to somebody.
yes, ma'am, yeah, that's true.
What would be the cost?
Yeah, yeah. 5 to 6,000.
How do you say that? Have you
I will
considered
show this in
the
office.
cost of your idea, the manpower, and all those things?
Yes, ma'am, including all those, we have cut down to 5 to 6K, ma'am. Actually, it will cost less than 5 to 6K for us. For selling, it may be around 5 to 6K.
Okay. Another question is, what is the overall weight of the device? See, somebody has to wear it on
Yeah,
them, no? What is the total weight
yeah,
of all
yeah.
these 5 sensors and associated accessories?
Ma'am, weight, we have actually not calculated, but it will be less than 5 kgs.
5 kg.
Ma'am, like we are using 5 sensors. 5
So
devices
what?
will be connected to each person.
I don't think any Arduino board will weigh 5 kgs. Anyway, you have to find
Yes,
out.
ma'am,
Okay, whenever
less
you are
than.
making a product,
Oh,
these are all the things,
yeah,
especially a wearable product. These are the things which you have to keep
yeah,
in mind. And how comfortable is the product
yeah,
to be owned by the blind, all by himself? See, nobody will be there around always, no? They have to wear it by themselves.
yeah, yeah.
Yeah, how comfortable is that?
Yes.
Have you tried it?
It's like normal
Wearing with
watch, they can wear
closed
it,
eyes?
or they can. Actually, I'm not able to hear your voice clearly.
Hello? Are you able to hear me now?
Hello.
Hello?
Yes. Oh, yeah, ma'am, tell me.
How
Clear.
comfortable is the sensor to wear all by himself by a blind person?
Yeah. Yeah. It's very comfortable as we wore watches and all. They can wear it like watches, or they can use it like hand gloves, or they can wear it on their jackets or glasses as well.
Okay, ma. Good idea. Thank you.
Okay.
Yes,
Thank
Nishit,
you. Thank you.
I have some questions. Uh,
Yeah.
so, how is your proposed implementation comparable with whatever existing methods are there?
Actually, existing methods, they are using other technologies like programming. We are using IoT based.
IoT based, what are the sensors you are using? Sensors people have
Um,
used
I-
before, right?
yes, ma'am. We are using ultrasonic sensors.
Then that's all? Only one sensor?
Yeah. And yes, ma'am. Only one sensor.
Only one ultrasonic sensor? Does it?
No, 5 actually.
Oh, 5 ultrasonic sensor,
Yeah,
one
yeah,
in each direction or something like that.
yeah, yeah.
Okay, okay, okay. So there are no existing products which uses ultrasonic sensor.
No, their ultrasonic sensor it's there, ma'am.
Ah,
But they are not using IoT based and all.
okay. What is IoT in your product?
Ma'am, we are using Arduino to program it, ma'am, using IoT.
No, because you are using Arduino, that doesn't mean that this is IoT product, right?
Yes.
Ah, so what are you I understand that you have to do some computation in the cloud and then convey it through the network to the mobile phone or something like that and all, right?
Yes, ma'am, yeah,
Ah,
ma'am.
so Arduino board usage doesn't mean that it is an IoT based product, right?
Yes, ma'am.
Yeah.
We have developed a program
No,
and we are dubbing it.
What is IoT in your implementation is was my question. If others
Oh,
have
okay.
answers also, they can say, the group members. Only Nishit is talking all the
Yeah,
time. So anybody
yeah,
has
ma'am. Let
answer?
my
Answer for what is IoT in your product? No?
no,
Okay.
ma'am, actually.
Okay. So usually when you propose a product idea or a new
Yeah,
implementation or something, it's better you go
yes,
through the literature, because this helping the blind, the people are doing for quite long. And there are a lot of
yeah,
hardwares already available. And you
yes,
have to go through the literature survey, tell us what has been implemented, and then you have to propose your idea, because you may end up inventing the wheel again. See, you have already, if this
yes,
product is there, then there is
yeah,
nothing novel in your implementation. It is just an implementation of the idea which is already there.
exactly.
Okay. So better you
Yeah,
do some literature survey, understand what all the products
sure.
available before, then you do this. And as madam told, Sri Lakshmi madam told, you have to make a blind person wear this and understand his comfort, because you do
Yeah,
some product and the blind people says, no, we don't want this, it's quite heavy, it is not reliable or something like that, then it's of no use.
yeah.
So always you
Yes,
have
ma'am. After
to try. Yeah,
implementation, we do it.
yeah, yeah, correct. First
Sure, ma'am.
you try with your
Yeah,
group mates itself. You can pretend that
yeah,
you are blind and then try. Then you will understand what are the problems inherited in your product. Then you can try for the
yes,
actual blind person. Good work,
yes,
but you have to do it systematically, compare with the existing algorithms, etc.
yes.
And
Sure.
better you continue this project for your major project also. So the volume of the project will be quite more. So you can come up with a very good product, maybe make it small and make it fast or something like that. Okay.
Yeah,
All the
yeah, ma'am,
best.
sure.
Yeah. All the best. Thank you.
Thank you. Thank you.
Thank you, ma'am. So we'll move on to the next one. Mm, Institute of Technology. The project title is Pariksh, a healthy diagnosis system for early detection and prevention. Is the team here?
Yes, ma'am. Good morning.
Uh,
I'll share
so
my
you can
screen
start
now.
with your.
Yeah.
Yeah. Ma'am, for the jury members, the evaluation sheet is already shared in your mail.
Sudha, are the
Yes,
titles
ma'am.
there in the evaluation sheet?
Yes, ma'am, it is there.
Okay, ma'am. Okay.
Yeah, okay.
Shall I start, ma'am? Okay.
Yeah, you can start.
Okay. A very good morning, everyone. I'm Vaishnavi Bhandarkar. Hope you're all doing well. Today, we are presenting our final year project, that is Pariksha Health Diagnosis System for Early Detection and Prevention. First of all, thank you for giving this opportunity to us to present our project. Me, my teammates Shweta, Zikra, and Yashaswini are a part of this project. So we will continue with our presentation now. So these are the contents of our presentation today. So there's a lot of improvement in the healthcare sector of the various different areas in the human life. So our project initially utilizes ECG sensor, pulse sensor, body temperature sensor, and heart rate sensor to collect the information about the conditions of the human body. Data set is prepared and the machine learning model is trained. And this information obtained from the sensors is passed on to that machine learning model, which analyzes the data from the collection of the data sets and predicts the health status of the person. So this can be used for early prevention and detection. Also, the reports obtained are displayed on the screen. So this is the literature survey. The top 3 papers which we have used is, the first paper is disease diagnosis by Nadi analysis using Ayurvedic methods with portable Nadi device and web application. In this paper, we have found out that Vata, Pitta and Kapha are the 3 Nadi signals that are used to diagnose various different illnesses. This is based on Ayurvedic traditional methods. So these signals contain the primary diagnosis of disorders of the portions of the body. The focus of this research paper is on diagnosis of asthma, hypertension, low hypotension, and gastritis. This is all experience on the part of the physician. The next paper we have used is machine learning in medicine, review, applications, and challenges. According to the proposed taxonomy, the machine learning model is based on machine learning based schemes in healthcare are categorized based on data pre-processing, learning methods, evaluation methods, and applications. The third paper we have referred is signal processing techniques for removing noise from ECG signals. So the ECG signals contain many noises, including baseline wander, power line interference, EMG noise, electrode motion, artifact noise. So these noise can be filtered, and different filtering techniques can be used to remove the noise. Moving on to the objectives of our project, which is to acquire the human body signals, including ECG, a PPG, that is Vata, Pitta, and Kapha signals from the pulse wrist of the person, the SpO2 value, and the body temperature using various different signals. Then to display the real-time PPG and ECG signals on the LabVIEW screen. Then we are filtering and processing the signal by extracting useful features and analyzing the signal pattern. Then we are finding the statistical parameters like mean, variance, and standard deviation of the stored values using NI LabVIEW functions. To apply supervised machine learning algorithm, that is KNN, and classify into various disease patterns like abnormal, diabetes, and hypertension. Then to display the health status of the person on the screen. So moving on, my teammate Zikra will be continuing the presentation.
So on the screen, you can see the system block diagram wherein our main device is Myrio, which we have interfaced with the pulse sensors. We have 3 pulse sensors, namely Vata, Pitta, and Kapha. We have an ECG sensor, which is AD8232 ECG sensor module. We have also interfaced LM35 temperature sensor and MAX 30100 pulse oximeter sensor using ESP32. So coming to the methodology, the PPG signals, the methodology is divided into 3 parts. It is acquisition, processing, and display of the results. Coming to the acquisition part, the PPG signals are acquired by fastening the pulse sensor strap, as can be seen in the image. The pulse sensor strap is fastened on the subject's wrist on the radial fossa artery of the left hand, and the ECG signals are acquired using AD8232 ECG sensor, and the patches, that is namely the left arm patch, right arm patch, and the common lead is placed on the subject's left arm, right arm, and the right leg as it is seen in the image. And then if the acquired pulses are of the right shape, they can be stored in using LabVIEW functions. The body temperature is acquired using LM35 sensor, and wherein when the subject is instructed, he or she has to place their finger on the temperature sensor, and similarly the SpO2 sensor is also interfaced, and all the above mentioned signals are read into the LabVIEW using Myrio. So this is the block diagram which we have developed in LabVIEW. So this figure on the left shows the acquisition part wherein Mario channels are opened and are read accordingly and stored onto the TDMS files. And figure on the right shows the temperature and SpO2 sensing methodology. That is that a message is displayed wherein the user is instructed to place a finger on the sensor and temperature is read and similarly SpO2 levels are read. Coming to filtering and processing, the PPG signals are filtered with a low-pass filter having a cutoff frequency of 10 Hz to remove the noise, and ECG signals are filtered with a low-pass filter of cutoff frequency 20 Hz, which removes the power line noises, and also having a cutoff frequency. Useful features from all the four signals, which include the number of cycles, mean cycle time, mean pulse area, arithmetic mean, RMS, standard deviation, and all other statistical features are extracted. And this set of features are given to a machine learning model, which is KNN in our case. So it is provided with a training data set, and the test data set is the one which we give. So from this test data set, it predicts the classification label based on the majority voting of the k-nearest neighbors. So this is the filtering sub-VIs which is developed in LabVIEW, wherein the signals are amplified in order to make a computations easier. Then they are filtered using a low-pass and high-pass filter respectively. And then all the statistical features are extracted, and features related to the number of cycles, mean cycle area are extracted. And also the pulse area is also computed, and all of them are arranged into an array, which is called array of features. This is the sub-VI which we've used for KNN classification, wherein the train data set is already provided, and the test data set in the form of an array, that is the array of extracted features, will be provided as a test data, and then the predicted labels are mapped to their corresponding string indicators. So coming to the data communication part, the results which are obtained are communicated to the user via the LabVIEW front panel using a graphical interface. Coming to the results, I'll let my friend Shweta continue with the presentation.
You have exceeded your time limit. Make it fast, no?
Yeah, yes, ma'am. Only three slides are there. So coming to the results, in the figure 9, we can see the raw Vata waveform which is acquired, which is then passed on to a low pass filter. The filtered waveform is displayed in figure 10, and the figure 11 and 12 represent the FFT of noisy Vata signal and filtered Vata signal respectively. The same procedure is carried out even for Pitta and Kapha waveforms. Coming to the ECG results, the raw figure 9 represents the raw ECG results. The filtered waveform is shown in figure 10, and the figure 11 shows the FFT of noisy ECG signal, which is then passed on to a low pass and high pass filter to obtain the FFT of and FFT of filtered ECG signal is displayed in figure 12. So this is how the result will look like, the final results with all the extracted features, dominant signal, and the predicted result for PPG, predicted result for ECG, SpO2 level, temperature, and heart rate, all will be displayed on the front panel. So now I would like to play the implementation video. Hello everyone, welcome to Pariksh, a health diagnosis system for early detection and prevention. In the hardware setup, ma'am, are you able to hear the audio of the video, ma'am?
Yeah.
Yes, go ahead.
Yes. We have used National Instruments MyRio Embedded System Board. The acquisition of pulse signals is done using 3 optical pulse sensors. The ECG acquisition is done using 3 lead ECG sensor. The temperature is acquired using LM35 temperature sensor. And the SpO2 level is measured using the MAX30100 pulse oximeter sensor. Firstly, the pulse signals Vata, Pitta, and Kapha are sensed on the subject's wrist, and small markings are done. The pulse sensors are placed near the markings, and the strap is fastened around the wrist. Next, the left pad of the ECG sensor is placed on the left arm, and the right pad of the ECG sensor is placed on the right arm, and the common pad is placed on the right leg. The subject's finger is placed on the temperature sensor and the SpO2 sensor when instructed. As you can see on the LabVIEW front panel, the details of the subject must be entered, including name, age, and sex. The deployment takes place and the real-time acquisition of Vata, Pitta, Kapha, and we'll play the video separately, ma'am. Second. Yeah. Acquisition of
Is it
Vata,
over?
Pitta, Kapha, ECG signal. Sorry, ma'am. Shall we continue with
Is
the
it
video?
over?
No, ma'am.
Oh,
Some
make
more
it
part is left. Yeah. Are observed.
Finish it off fast.
Yes, ma'am. These signals are then stored. Next, the subject is requested to place the finger on the temperature sensor and the temperature value is acquired. The subject is then requested to place the finger on the SpO2 sensor and the SpO2 value is acquired. The results are ready. The raw signals of Vata, Pitta, Kapha and ECG signals are displayed. And then the filter signals with the respective FFTs are displayed. In the results tab, the PPG dominant signal, predicted result from PPG, predicted result from ECG, SpO2 level, the body temperature value in Fahrenheit, and the heart rate is displayed. Thank you for watching this video. So coming to the conclusions and future scope of this proposed methodology, we would like to conclude that the pulse and ECG signals have been successfully acquired and filtered. A data set of extracted features was created and machine learning models were developed. Specifically, KNN yielded up to 84% accuracy for PPG and up to 43% for ECG signal. We would like to mention that the efficiency of high-pass filter used to remove the baseline wander in ECG has been very inconsistent. So a more efficient technology can be developed to achieve the same. One more thing to be noted is the accuracy and performance of the machine learning models can be greatly improved with the provision of larger data set. For this, we would require standardization of acquisition divide and the data set. Further, involving doctors and medical professionals for evaluation and feedback would make the diagnosis system even more accurate and trustworthy. So these are the papers we have referred for our this project. Thank you.
Okay. Thank you, Vaishnavi and team. Now I would leave it to the jury members to ask questions.
Thank you, team. Nice idea and implementation. I have a question. Am I audible?
Yes,
First of
ma'am.
all? Yeah.
Yes, ma'am. Yes,
My
ma'am.
question is, how much percentage of the hardware is done by you? Me in the sense, did you do the soldering and other things, or you brought the available modules and assembled them and programmed?
Ma'am, we brought the available sensors and we programmed them, ma'am. Like we connected them, and the entire software part is done by us.
Okay, what is the language you have used for software?
The software is, we have used a graphical language, ma'am. There is a software called LabVIEW which allows graphical programming. So we have built the entire project using that.
Okay. So it would have been better if you had given the analysis also of your results involving some medical professionals, as you said. It would complete.
Yeah, ma'am. We actually went to a clinic, Ayurvedic clinic only, and we got it reviewed by the doctor there. And she told that the technique which we've used to predict the dominant signal is correct.
Okay. Again, the same question which was asked for the previous one. What is the costing of your project? This is a
Ma'am,
product, right? Which you want to sell.
yes, ma'am. So it costed around 2,500 rupees, ma'am, excluding the embedded system, that is my Rio board, which we borrowed it from the college.
No, I'm asking you the overall cost. If I have to buy it from you, how much should I pay you?
Like Myrio itself costs around 50,000 rupees, ma'am. We are planning to develop a low cost device using ESP32. So the current cost of our project would come around 52,200 rupees.
Okay. Is it for a 8th semester project or a 6th sem one?
8th sem, ma'am, final year project.
Final year project. Okay. So how different is this from the existing systems? There are a lot of gadgets available.
Yes, ma'am. We have tried to incorporate traditional Indian diagnosis, wherein we have read 3 pulses, and we are also reading ECG using this. So, existing systems in the market don't have this capability.
Are you sure?
Ma'am, as of now, I mean the small miniaturized systems don't read so many signals, ma'am. They read only heart rate and SpO2.
Like there are various products, ma'am. Either one reads only the pulse signals, or only ECG signals, or only body temperature, or only SpO2. Our project does everything. All these 6 signals we read. So, and it also gives
Okay.
the health status of the person.
Okay. If you have to complete the project, you should also make a packaging and then sell it as a product with the cost. Okay. So
Yes, ma'am.
then it would become a complete product. We would also like to see how it looks like in a package, no? So
Yeah.
what is the power requirement?
Power requirement is around 9 volts, ma'am.
Single 9 volts battery is enough.
No, ma'am. We can just plug in the device to the power supply, and it will be converted to around 9 volts. That is, Myrio will be the one, the embedded system which we are using. So 9 volts is the power supply
So
provided to the entire.
can we not make it portable?
Yes, ma'am. We can make it portable.
So I think you can at least make so much. Either it should be plugged to a device, I mean a power point, or it should be operated by a battery.
Yes, ma'am.
You can give
It
both
can
the
be
things.
operated. Yes, ma'am.
Okay. Okay, ma, that's all I have. Nice project. Thank you.
Yes, ma'am. Thank you very much, ma'am. Thank you.
Thank you, ma'am.
Yeah, good project, nice try. But you have to confirm that if you are measuring all the 3 pulse based on Ayurveda, is it really required to detect the diseases? Or you can't just measure and say that this is not required to detect some diseases, correct?
Yes, ma'am.
What are the
We
diseases you are trying to detect?
Ma'am, it's diabetes, hypertension, and cholesterol, ma'am.
Okay, so all the 3 you were able to detect with that accuracy, that 84% or something you are told?
Yeah, ma'am, we checked the accuracy of the data set and it was 84% it showed, ma'am.
That is for training.
Yeah, ma'am.
Oh, for the testing you didn't do. You didn't
Ma'am,
test
we
with the
couldn't.
other patients.
Yeah, ma'am, we couldn't actually find patients of those, so we couldn't test it properly. But the data set the data set is also created by us only, ma'am. Like we only acquired the pulses. So for
No,
testing, we couldn't.
my question is, see, there is already there is a measurement of diabetes or hypertension using the pulse rate and all those things, right?
Ma'am, yes, ma'am.
How do you justify that this measuring these 3 waveforms and predicting diabetes or hypertension is better than the other signals, is what my question is, correct?
Yes, ma'am. Like
Ah,
this is a non-invasive one, ma'am. Usually diabetes is detected using blood, like they draw blood and then do the blood test.
correct.
So we've tried a non-invasive method, ma'am. Like you don't need to take out any blood. We can just place the sensors and read.
But hypertension can be detected using ECG only, right?
Yes, ma'am. It can
Ah,
be up to some extent, but
correct.
PPG is a better this one, ma'am. Better measure signal for hypertension.
Okay. So that is one thing you should justify, like why you are measuring these three signals based on Ayurveda
Because
compared to
PPG is
ECG.
based on volumetric changes in the blood. So
Correct.
P would be more properly detected within PPG rather than ECG.
Okay. That is the one part of your project. The other one is, I think you are just having the prototype now because you are using the Myrio board, right?
Yes, ma'am.
So you have to think of replacing it with Arduino or some other embedded board such that it comes out as a product, right?
Yes, ma'am. Yes, ma'am.
Or if you want it as a wearable, then you have to think of some other processor also.
We
So
can't do
only
it as
your
a variable, ma'am, because
correct.
ECG requires 3 leads.
Correct. Okay. So if you want to make it as a product, then there is a lot of work which will go into this, but it's
Yes,
a good idea.
yes, ma'am. Thank you, ma'am.
Can I ask you why this name for your project? What is the reason to have this name for your project?
Ma'am, Pariksh is a like Sanskrit word.
Ah,
So it's that kind of friendly device which can predict the health status of the person.
the
So
meaning of
basically,
pariksha is what in Sanskrit?
testing, testing.
Yes. Oh, pariksha. Okay.
Yes, ma'am, Pariksha
Okay,
testing.
okay, okay. Good. Just was very curious to know that. Okay,
Yes,
thank you.
ma'am.
Good work. Yeah,
Thank you very much, ma'am, for all your inputs and suggestions.
yeah.
Okay. Thank you, ma'am. Thank you, Vaishnavi and team. Will it is CIA machine learning classification approach for detection of COVID-19 using CT image. So this is again from JSS Academy of Technical Education. Is this team here?
Yes, ma'am.
Okay. So you can start with the presentation. The next team, keep your presentations ready. We have another two teams. One is from RNSIT again, and one is from Sahyadri College of Engineering, Mangaluru. Keep it ready, Hmm. Yeah, you can start with this. You can start your presentation. Vaishnavi? Vaishnavi?
Good morning, one and all present here. Yes.
What happened? Vaishnavi, you are not audible.
Aren't we audible now?
Now you are audible.
We were sharing the screen actually.
Yeah, that was visible, and your voice was like not clear and it was breaking.
Okay. Just
Your screen was there.
is it audible now? Our voice?
Yeah, yeah. Your screen is also visible and you're clear, audible. put it in presentation mode and start, no?
Yes, ma'am. We have put it in the presentation mode.
Yeah. Make it fast.
Good morning to one and all present here. We are from JSS Academy of Technical Education, Department of Electronics and Communication, and our project title is CIA Machine Learning Classification Approach for Detection of COVID-19 using city images. And we are third year students, and our team is Darshini, Vaishnavi, Raghunathan, and myself, Spurti. The faculty in charge are Dr. V. Padrapa sir and Mrs. Suguna. Coming to our presentation, this study represents the early phase of detection of novel coronavirus disease, COVID-19, which is one of the most infectious disease in 21st century, caused by SARS-CoV-2, was first discovered in Wuhan, China, and spread to countries. The symptoms were cough, loss of taste, fever, tiredness, respiratory problem. These symptoms were highly to show within 11 to 14 days. Some of the biochemical tests like RT-PCR and rapid antigen tests and also X-ray NCT images were also used in detection of COVID-19. In this presentation, we analyze city, that is computer technology, and classifying COVID and non-COVID images based on texture feature techniques. In particular, we use DLCM statistical features and Pearson correlation. Main aims and objectives of a presentation is machine learning methods to access just images of COVID-19 patients, analysis and classification of COVID and non-COVID cases during pandemic. The main objective of this project is to review the role of MI as a comprehensive and decisive technology to fight against the COVID-19 crisis, the fields of diagnosis and disease progression. The supporting architecture is as follows, that is in 3 steps. The engineering, feature selection, and modeling. Initially, the pre-processing is done. The features are extracted. Since all the features can't be selected, only relevant features can be selected. So the selecting criteria is Pearson correlation. Once all the features are extracted, it is sent to the modeling. Coming to the methodology, first, in feature engineering, we use pre-processing. That is, the CT images were resized from the regular size to 115 to 150 pixels. After resizing, all those were converted into gray images or grayscale. In the pre-processing, a Kaggle database consisting of 1252 and 1229 CT scan images related to COVID and non-COVID images were selected equally in number for processing. We have developed 2 significant features for our process by feature engineering, and those are gray level co-occurrence matrix, GLCM features, statistical features. Coming to GLCM features, these are obtained from gray level co-occurrence matrix. They show the relationship between the pixel values in the different angles and different distance. The GLCM features such as correlation, contrast, angular second movement, difference entropy, and difference variance were extracted. Some of the statistical features from first to fourth order are mentioned here. That is mean, median, standard deviation, variance, mean absolute deviation, robust, mean absolute deviation, range, entropy, skewness. Statistical feature deal with the appearance on a gray level scale based on histogram. Coming to feature selection, here we use Pearson correlation coefficient to select features based on highly correlated features. Features with highly correlatable are meant to be linearly dependent and hence have some effect. So features high correlation either of them are histogram and CT scan images. The histogram highlight describes the negative skewness in COVID. COVID images with black values has lesser values and white values has more. In non-COVID CT scan images, histogram is positively skewed, that is 0 represent black. So we can say that black has more and white values are less. Coming to the implementation of models, we use SVM and random forest models. SVM is one of the most commonly used classifiers because it has a high accuracy. It is based on matching the 3D space using linear and non-linear method. And random forest involves in formation of decision trees where random defines addition of randomness to the model. These are the statistical features extracted for respective COVID and non-COVID images. GLCM features extracted, results are shown over here. Coming to our results, classification results of statistical and GLCM features for COVID versus non-COVID using two different classifiers are shown here. Uh, uh, Therefore, obtained results from the models, that is SVM and random forest, were validated with 5-fold across validation methods. In our model, we achieved the classification of the model and 5% using random forest respectively. By concluding a project, we can say that these findings showed that radiologists can readily observe and classify the patient as COVID-19 positive or negative using the before mentioned approach. Finally, two ML classification models were built, and it can see that the random forest classification algorithm outperforms the SVM and random forest algorithm in terms of accuracy and prediction time in this dataset. Yeah, thank you.
Thank you, Vaishnavi. You have anything for demonstration or any video?
No.
Okay. Yeah. So now I leave it to the jury members.
Thank you, team. It's a good effort. But
Thank you.
recently, lot of methods have come for detection of COVID-19, especially after the pandemic. So how different is your method? And how simpler and
Actually,
quicker?
yes, ma'am. Actually, we had like done this project in the initial stages of COVID-19. So when it was like lesser than like as the time varied, it increased. So at that time, we tried this project.
Okay, how many data sets did you get for training and how much did you use for actually testing and validation?
Ma'am, actually, we got in terms of CT images, like we got around 1 to 5 to and 1 to 29 CT scan images related to COVID and non-COVID.
Which hospital?
No, ma'am, it is from Kegel dataset.
Okay. Any specific reason for choosing SVM?
Ma'am, actually, usually for these kind of images, SVM and random forest, like when we did the literature survey, we found out that SVM and usually random forest performs better for these kinds of data sets, for especially classification.
Okay, what is the accuracy that you got out of the two algorithms?
Ma'am, for SVM, we got 91%, and for random forest, we got 94.5%.
Okay.
Like after applying cross validation.
Okay, that's it from my side.
Okay.
Good try, but I think it's quite late now. I think you would have done it very early, but now it's
Yes,
quite
ma'am.
late, I think.
Actually,
Yeah.
like after that, we also did for latest data, we also did for using deep learning techniques.
Okay, okay.
For the future scope,
Yeah.
we did it for the latest data also.
That's what is the question I wanted to ask. Why not deep learning? You can get away with all this feature extraction and all those things, right?
Yes, ma'am.
You can directly
Yeah.
do the classification.
Yes, ma'am. Like first, we wanted to try with ML.
Okay.
Like after understanding those basic concepts, only we can go for DL. So we tried like that.
Okay. Then another question, I thought SVM should perform better than random forest. I think you should do a recheck again. Okay.
Ma'am,
So
actually
just-
for this data set, random forest outperformed.
Even I
Probably-
felt so, like madam.
Yeah, I think the parameters, whatever they are using, somewhere I think they
Maybe
have
they'll
a
have to
lot of
recheck.
parameters.
SVM
Yeah,
is the
yeah,
best classifier. Yeah.
correct. That's what.
Yes, ma'am. Probably like we applied cross validation. So after that, we got these results actually.
No, it's better you recheck. I am not telling you are wrong, but that's what we understand. SVM is better than random forest, but you can just recheck it once. Okay.
Yes, ma'am. Sure.
And then why CT scan images? Why not chest X-ray images?
Ma'am, like in CT scan images, we have like usually CT scan images, we can easily detect all those features, but in a better way.
But it's costly, right? Everybody can't afford to do CT scan, right?
Ma'am, but during the COVID-19 period, CT scan images were most of them CT scan images were used. So
No,
the data.
Kaggle itself has chest X-ray images also, ma. So why don't you try that also? Okay.
Yes, ma'am.
And only 2-class classification you have done, so SVM should perform better. You are just telling COVID and non-COVID. You are not differentiating between pneumonia, lung opacity, and all, right?
Ma'am, next, like using other next, like we had done in stages, ma'am. First, using two classes.
Okay.
And for using those 4 classes, like as you mentioned, we did deep learning techniques.
Okay. Thank you, ma.
Thank you.
Thank you, ma'am. Thank you, Vaishnavi and team. We'll move on to the next one. We have abnormal event detection in videos using spatio-temporal autoencoder from RNSIT.
Yeah. Hello, everyone. Good morning.
Is it
Good
clear?
morning. Yeah. Is my voice
Yeah.
audible?
Yeah, clear.
Okay, cool. Yeah, I am Yakshata. Thank you for giving the chance to present our project. So I am from RNSIT, and my teammates are Abhinav, Hiteshini, and Elias Raj. We have done abnormal event detection in videos using spatio-temporal autoencoder. I'll just start sharing my screen. Is it visible?
Yes.
Okay. Yeah, so this is abnormal event detection in videos using spatio-temporal autoencoder. So this is the agenda. And if we go with abstract, so what is an abnormal event? So there might be many abnormal events happening. So today the video usage is very much, and everywhere you go, you have a surveillance. Everywhere you go, you are detecting what is happening in everyday life. So there is massive amounts of data. But what do we do with that data? Why do we put a video, for example, for any surveillance? We want to know what is if there's any abnormal events happening. But manually sitting and analyzing every video, if this has some abnormal events, if this has some normal events, it's not possible, right? So with the massive amount of data, so our aim is to automate that thing and help the surveillance system so that it will raise an alarm whenever there's an abnormal event happening or anything. So we are using a convolutional neural network, mainly as a recurrent neural network, in order to detect those abnormal events happening. So normally there are 3 techniques: supervised, unsupervised, semi-supervised, right? So with this, supervised are the existing techniques, but what we have done is a semi-supervised. So what we'll need is a normal event. So whenever we are training our model, we train our model only on normal events, and during testing we provide both normal events and abnormal events. So this is the introduction. So what is an abnormal event? So it's just a rare event which is very different from a normal event. So abnormal events won't happen that uh, regularly. It happens occasionally than compared to normal events. So, and also one more thing is an abnormal event is highly context specific. So whenever we're talking about context, so if I talk about pedestrian, okay, so normally driving a car on a road is very normal, but if you drive the same car on the pedestrian, it's an abnormal event. So this is an example of context specific. So whenever we're taking an abnormal event, it is highly context specific. So that is a very great challenge whenever we are implementing any project related to this abnormal event detection. So we are proposing a spatio-temporal architecture for abnormal event detection in videos. So what is that architecture? We'll see the later. So this is the literature review we have done. So this is the base way we have taken, which is anomaly detection using convolutional autoencoder. So we'll use an autoencoder, which is having spatial autoencoder and temporal autoencoder for detection. Next, we have learning spatio-temporal features using 3D convolution networks. So we have also incorporated the 3D convolution network things from this paper. And next is spatio-temporal anomaly using deep learning for real-time video surveillance. So how we can use a spatio-temporal architecture in real-time surveillance to detect abnormalities is what we have taken from this paper. So next, problem identification. So what is the problem we're trying to solve? So the thing is, we are trying to solve any abnormal events happening in any video surveillance, live video capture. Okay, so it just have to raise an alarm or send a notification saying that some abnormal event is happening. So for example, it can also save lives. For example, if there is some accident, okay, so if it raises an alarm, someone can call the ambulance if no one is there in the environment, in the surroundings. So the person, when the trigger raises, the person who is hearing that alarm can call an ambulance and save the life. Or if some abuse is happening, if some harassment is happening, so that can get captured, that can raise an alarm, and someone can go there, rescue them. So all these things are abnormalities these days have been increasing like a lot, and an efficient method which can detect those and raises an alarm is a very much needed model. So we have taken that. So this is the world's most surveillance cities. So we can see Delhi is the first where the most surveillance is happening. So it's in India only. So these are all the most surveilled cities. Objective is to develop a system which will detect anomalies in real time. It should be able to detect in real time. And next, we have to handle different kinds of anomalies. Anomalies will be different kinds. For example, abuse is one kind of anomaly, fire is one kind of anomaly, explosion is one kind of anomaly, robbery is one kind of anomaly. So we have different kinds of anomalies. We have to incorporate as many kinds of anomalies as possible is what is our objective. And next one is to be integrated. Whatever system we develop, it should be able to integrate with the other existing systems easily. And to detect the frames which are deviating from the normal frames. Normal frames will be having a particular pattern, whereas abnormal frames will be having different pattern. So what is the methodology? So first methodology is, first we are giving an input video and we are extracting the images from those videos. And next we are performing some pre-processing steps like resizing of the image to specific image, because all the images we extract will not be of same size. So for a model to be learned, it should have a specific size. So we are resizing it to 227 cross 227. All these numbers, what we are taking is a standard one, and we have inferred it from the papers or the literature survey papers we have done. Okay, so that's why we are using the same numbers, and we are scaling all the pixel values between 0 and 1. We are performing grayscale conversion for the dimensionality reduction and normalization. All of these things are the pre-processing steps that we're carrying out on those image frames. So once we get those image frames, we are taking 10 image frames as one bunch, and each bunch will be analyzed by our model, and it will tell whether the bunch is normal or abnormal. If there are some frames in a bunch of 10 frames, okay, say it's abnormal, it will raise an alarm telling that there is some abnormality in this bunch, check. Right? And the architecture has two main components, spatial autoencoder and temporal autoencoder. So now what is spatial and what is temporal? Okay, so spatial is nothing but about the image. It is restricted to only when we take one image frame. Okay, so in one image frame, what are the things happening? So one image frame might have a cup, human being, any other things in the image frame. So what is present in that image frame must be identified by the model. So that is called as spatial feature. Spatial feature is what is the things present in one image frame. Next comes temporal. So what is temporal? The one difference between video and images, video will be sequence of images, right? And sequence of images will have some particular action, right? In an image, there might be some missing actions. The thing is, we have to analyze what is the action being performed in order to tell whether the video is normal or abnormal. So when we are converting those videos into images, we will lose what is the action being performed. So in order to preserve that action, we are using temporal. Temporal is nothing but what is the action being performed in the previous image frames. So whatever 10 image frames are there, this temporal autoencoder will combine those 10 image frames, and it will analyze what is the action in those 10 image frames. Right? So spatial autoencoder is restricted to particular image frame, and it will tell what are the features. It will make a feature map in a particular image frame using the spatial autoencoder. And what we are using is we are reconstructing the input. We are using convolutional layers to extract the features, and then we are using spatial encoder, which is having 128 filters with size 11 cross 11. 11 cross 11 is the matrix size of a filter, and such 11 cross 11 filters we are using 128 in order to predict. Next step comes the 64 filters with size 5 cross 5, and then decoding part we use same things but in the reverse part. So what we are trying is we are trying to reconstruct the input video. Say we give one video to the autoencoder. Okay, if I go here, so this is a video input. We are converting to image frames from a video. Then we are converting into grayscale so that dimensionality reduction happens, because colored images have no information. It's same as grayscale information. It needs only information to tell if there's a normal event or normal event. So we are converting it, and then we are giving it to autoencoder. So what happens in autoencoder is we are trying to reconstruct the given input video, right? But the output of the autoencoder will be what it has understood from the given video. So for the first time when we give the input video, the difference between the original video and the reconstruction video will be very high, because initially it will not have learned so much. But as we go on training the model on the same thing again and again and again, it will learn more and more and more, and it will reach same as given input original video, and the reconstruction video will be same. So what we're trying to do is we are trying to give the normal events as videos to the autoencoder. It will construct a spatial encoder, will detect what is present on the frames, and temporal will use a LSTM unit, because it has to keep in memory what are the previous 10 images it has seen, right? Because we are specifying one bunch as 10 frames. What is present in the 10 frames must be remembered. So for that we are using an LSTM as a memory unit, and this temporal encoder decoder will combine those 10 images. It will analyze what is the action being performed, and it will give it to the deconvolution. Convolution will make a feature map of what is present on the images, and deconvolution, using those feature maps, it will try to reconstruct the same video, and it will give the output. Okay, so what we're trying is, as normal videos are being trained in the training phase, it will have known what is the meaning of a normal pattern or normal video. It will have learned what is the pattern of a normal video. So during testing, when we give the abnormal events as a videos, it will not have seen that during the training phase. So it will automatically classify it as a abnormal event happening. And we are using some threshold. So we are using reconstruction error. Once the reconstructed output video is come from the autoencoder, we will measure what is the difference between the original video and the reconstructed video. That is called as reconstruction error, right? And on that we'll put a threshold. Okay, so we'll tell if the reconstruction error is greater than some threshold, then it is an abnormal event, else it's a normal event, kind of a thing. So this is a sequence diagram. We are making a terminal to model. From processor.py will extract the frames, convert it into grayscale, and then give it and performs all the normalization and pre-processing steps and give it to the terminal. Terminal will pre-process those bunches, give the pre-processed bunches back, tests, analyzes the bunch, and gives the output if it's normal or abnormal. And this is the algorithm we are using. Same as the sequence diagram. This is same as the sequence diagram. And this is start. Okay, so we are giving the original clip and we are calculating the reconstruction cost, what is from the autoencoder. And if the reconstruction cost is greater than threshold, then it's abnormal clip, else it's a normal clip. We're telling this is the testing. So this is a person sitting and talking. So this is a normal event. And this is a fighting video, which is an abnormal event, choking or fighting. And what we have taken, there are two standard data sets for this: Avenue dataset and UCSD dataset. Avenue dataset is about a subway dataset. It's just a camera capturing the subway things, whatever is happening in US. It's a subway in US which was captured. And next one is the UCSD. It is about a pedestrian dataset. It is that location is also placed in the US. So both are the standard datasets, but we have used as real life violence dataset. What we have used, so whatever it has violences like fighting, choking, or some other fight scenes, everything. And normal videos are like someone is giving presentation, someone is eating, someone is talking, someone is walking, or it's a normal videos. We have given all this to train our model. And these are the results. So this is processing where we are extracting the frames. So you can see this 5, right? So this 5 is the FPS thing. So if we say as 5, for every 5 seconds, one image frame will be extracted. If we say it as 1, for every second, one image frame will be extracted and it will analyze. And this is the train phase. We are giving number of epochs as the parameter. If we give 100, that means 100 times the model will train on the given input data set, and it will also print what is the loss accuracy for every epoch. And this is the testing phase where we are giving a bunch of normal and abnormal videos both, and it will tell whether there is an abnormal or normal videos present in the bunch. And this is the live video. So this is me and my friend. We have tried this out. So this is our RNSIT campus where we have tried out. So we have a module called a start live feed, where it will start to whenever we run that module, it will start to capture the live video, what is happening on the scene. Okay, so whatever happens, it will take for until and unless we tell it to stop, it will start capturing on the fly. On the fly, it will capture all the videos, and it will start telling whether this bunch is normal, abnormal, normal, abnormal, like that. As you can see here. And whenever there is an abnormality, it will raise a trigger to some sound kind of a thing will come. And whenever that alarm triggers, someone can pay an attention to it. So as you can see in the first thing, we are hugging. So it's a normal event. So it gave it as normal. And this is fighting, where we both are fighting. So it is giving anomalies detected. And it will give the frame numbers from which frame to frame there is anomalies present. Please check those frames. And this is the conclusion, where a deep learning model is used, and we have built a convolution LSTM and all. And the model right now gives 75 to 80%. If we give more number of epochs, there is a chance to reach 90 to 95%. But that is not proper way of doing, because overfitting will happen. So what happens with normally, if accuracy is more, it is very good. But for our project, if we reach the accuracy of 90 to 94%, it will learn the background also. So for example, here you can see this is a plain background. So in order to test, or in order to give the model a correct prediction, we'll have to give only plain background if the accuracy is more, because it will also have learned the background. So that's why, in order to not keep it overfitting, we have made it up to 80% of accuracy, and this is the standard accuracy for this project. And these are the future enhancements where we can try it on large data set. So right now, whatever data set we have, it has 1,000 videos of training data set, and testing data set, we have 1,000 videos. We have trained it on 1,000 videos. 1,000 videos itself is a very large thing for any normal laptop to be trained on. It hangs, and with the number of epochs, since it's a video, images are like very less memory occupying, but videos are very large memory occupying. So we can try it on a larger data set with more computing power. That's the restriction, that we need a more computing power. And we can train the model to detect more types of anomalies. We have trained our model on Avenue dataset, UCSD dataset, real-time violence dataset, all the three. And all the three have shown a very good results. And next is we can integrate YOLO, and we can use background subtraction. And we can also tell what is the type of anomaly happening if we want. And these are the references that we have taken, and this is a thank you. And if permitted, I would like to play a video. This is the live video that we have captured. Can I know if it's seen?
No, your time is already done.
Yes. Yeah, so this is just walking. So it's giving all normal, normal, normal. And this is just hugging, and it's all giving normal. And we'll just go here. And sometimes there will be false positives, false negatives, false such. And since the accuracy is 80%, sometimes it might miss out on giving some abnormal events also. Or sometimes it might give this as normal and abnormal events. This is the real life violence we are trying. And last one is banging on the wall. We have tried the banging on wall. Closing of the camera is an abnormal event. Shifting the camera is an abnormal event. And this is banging on the wall. We've tried out. Where it gives us abnormal events, it went here. I was banging her on the wall. It gives it as abnormal events. Yeah, I choked her and it was an abnormal event. Yeah, that's all. Thank you. I'd leave to any questions. And I'd like to mention upon one thing that I told we classify normal and abnormal based on threshold, right? So what is the threshold value? That threshold value, we get it after lot of training. After lots of training, we have to see what is the loss value for normal videos. For normal videos, the loss value will be very less, because it will have learned more during the training. It will have learned, or it will have seen so many videos. The reconstruction error will be very less for the normal videos, so the loss value also will be very less for the normal videos. But for abnormal videos, the value will be very high. So based on training phase, what is the loss value it is giving, we have to fix on one threshold value. After lots of training and seeing, observing the values, we fix on the threshold value. Yeah, that's all. I'd leave for any questions.
Thank you, Ekshita.
Okay.
Good
None
work.
any questions?
Sorry.
Yeah, good work.
Thank you.
But I have one doubt.
Okay.
Okay. So in this abnormal situation, like there is a fighting video what you shown,
Yes.
yours and your friends, or the second video what you showed. Okay.
Okay.
So see, it may not be fighting, but it may be that a person is falling down and the other person is trying to give him a
Picked up.
support.
Hmm.
So how does that gets considered as abnormality? Will your algorithm go into that depth, or it will just do it at the surface level?
No. See, the thing is, that's why we are having something called as temporal, right? So, what is the action happened before also we are considering, right? If someone is trying to help, that means in the previous video or previous action, they will be giving the hand, right? While if they are pushing, in the previous image frame, it will be pushing. The previous image frame will be like this. While if it is helping, the previous image frame will be like this, giving the hand, right?
Okay.
Understood? Yeah, like that.
Yes.
That's why we are having something called as temporal. That's the main difference between a video and a image. If it is a, yeah, you told it correct when it is about an image, but when it is a video, the previous actions also will come into picture, right?
Okay. Okay, ma. Good work. That's all I had.
Thank you. Any other questions?
Yeah. Did you compare your algorithm with some existing algorithms and measure the
Yes.
performance?
Yes, we did. Yes, we did. Existing algorithms are all trajectory based, and it is supervised. First of all, it is supervised. It is not semi-supervised. And as far as it will give, it will not work with the live video. See, whatever live video is there, it's a application. We have done an application part. Normally, people will just do a training, and then they will give the test videos in the folder, and they will tell, like I told the test, I showed you the testing phase, right, where it was giving bunch normal, bunch abnormal as to the console. So till there is the point what people will do. But what we have done is a one step more, which is an application. So this is ready to be deployed, right? So whatever we have captured, it's a live thing. So it's a ready to be deployed. We can just connect to a camera, and we can just start telling whether it's an abnormal or normal event. So that is there. And one more thing is accuracy. Accuracy is more compared to like existing ones have 79 to 80% same accuracy, but in application level we have gone one step ahead with the other projects, whatever we have compared. And it's ready to be integrated also if someone is at, and but the thing is we have to we need more computing power in order to make it more accurate. That's all. Now also it is accurate, it does gives, but sometimes false positives, false negatives, true positives, all those happens.
So what is the number of classes you have considered?
There is no classes, there is only normal and abnormal event.
That's all.
Yeah.
Okay.
So
So
it
are
will
you
take
planning to do the classes also? There are some specific classes which you can consider, right?
That's what is our aim, that we don't have to particularly tell about a specific context, what I mentioned. Okay, so we want to make it as general as possible, so it should be ready to be deployed at any place. Now if I go to road lane and deploy it, Okay, so there may be different abnormal events happening in the road lane, like abuse will be happening or some robbery will be happening, different kinds. And when I'm going to deploy it in the pedestrian kind, different abnormal events. So it's a highly context specific. What we are doing is not kinds of events that we want to employ. We want to deploy it as generic as possible, and it should be integrated with everything. Right, it's a very difficult thing to go beyond context specific thing, because if it is a particular context, I can just give some bunch of 1,000 videos of the same place and I can tell it what is the normal event for my model. It'll easily learn what is it. But when I'm telling about different contexts, different places, it's very difficult for the model to be to analyze that, right?
Okay. Thank you, Ma.
Thank you. Thank you, everyone.
Thank you, ma'am. Thank you, Akshita. We have the last team now. It is from Sahyadri College of Engineering, Design and Development of Autonomous Vehicle for Warehouse Management using ROS. Is the team ready here? Is the team here? Hitaishini?
She's from our team.
Okay.
Yeah.
Sorry for the interruption. Could we leave?
No, wait, no.
Okay, sure.
There's one more person here, participant, Mila S. Raj.
Yeah, she's also from our team.
Okay. Ma'am, then the team is not here. The last team.
Okay, Ma.
Okay. So before we end the session, I would really thank and appreciate the time and efforts taken by all the participants to do the presentations. And I also thank to our jury members here, Dr. Sri Lakshmi ma'am and Dr. Setu Selvi ma'am. Thank you so much, ma'am, for your time and your presence here for evaluating all the projects of the SigPro 2022. Lastly, I would request all of you to switch on your videos for a photo session. Vaishnavi? Yeah. Yeah, done. Thank you. Thank you all so much. Ma'am, the evaluation sheets are already mailed to you all. Please enter the marks and may reply back to the same mail.
Thank you, Ma. Okay.
Okay, ma'am.
Thank you.
Thank you, Setu, ma'am.
Thank you, Ma.
Thank you. Yeah.